and welcome to the second episode of Science Simplified of Bharata First. Through this show, we provide you the platform to let your curiosity out and ask any question about science and technology which will be answered by our expert. To send us your questions, you can submit it through a form whose link you can find in the description box below. Do make use of the opportunity, my friends. Now, I would like to introduce our science expert, Dr. Tv Venkateshwaran, who is here with us to answer the questions sent to us by our viewers last week. Dr. Tv Venkateshwaran is senior scientist at Vigyan Prasar, New Delhi. He is the founder editor of India Science Wire. His area of research includes science, technology, society, and he also writes regular columns on developments in science and technology. So, without much delay, the first question for today is:
Hello, I am Amit Kumar and currently I am working at Uttar Pradesh State Electricity Department in the Science Simplified program of Bharata First. My question is about Event Horizon Telescope. First of all, I would like to know about Event Horizon. What is Event Horizon and how significant EHT, that is Event Horizon Telescope, is in understanding our universe, or mainly black holes. Thank you.
Black holes have been an object of curiosity, and in fact, in today's world, it's one of the buzzwords that we talk about. So, in a very simple way, if one has to understand what is a black hole or one important feature of that black hole, we need to understand a concept called as escape velocity. What is this escape velocity? Suppose if I throw a stone, okay, that stone will go to a certain height and come back. If I give a little bit more impulse, you can try it out. The stone will go even a bit higher and then come back. Okay? If I give even more impulse, it will go even more higher and then come back. But every stone that goes up, will it come back? No. If you are standing on the surface of Earth, okay, and if you give an impulse of 11.2 kilometer per second, that stone will not come back. That's called as escape velocity. On the surface of Earth, the escape velocity is 11.2 kilometer per second. But suppose if I go and land on moon, I need to come back, right? So what is the escape velocity on the surface of moon? It's about 3.2 kilometer per second. Quite obviously, you can now guess that depending on the mass of the object or the gravitational potential of the object, the escape velocity will change, right? So suppose if I have an object whose gravitational potential is so much, the escape velocity is slightly more than the speed of light, from that surface, light cannot escape, right? Even if I shine light on that surface, the light will fall on that surface, get reflected, but it won't come out and fall back because light cannot escape. And the physics that we know today, nothing can travel faster than the speed of light. So, which essentially means nothing can escape from that object. Okay, that's an object we call as a black hole. So, black hole's one important characteristic is its escape velocity is more than the speed of light. So, suppose you are near a black hole. Okay, there will be a point in the near the black hole beyond which, if you go, the light cannot come out, or light will take infinite time to come out. Okay, it will be like a border around that black hole, right? I mean, it will be like a surface or a edge for that black hole. That is called as event horizon. Basically, it means that you can observe the events up to that. Beyond that, you cannot watch. It's something like, say, for example, if you are standing on the surface of Earth on a seashore, okay, when the ship is going from the seashore, you can observe the ship. After some time, you won't be able to see the bottom part of the ship because of the Earth's curvature. Okay, and after some time, you won't be able to see the ship at all. So basically, there is a horizon beyond which you cannot see the surface of the Earth, right? If Earth was flat, I mean, of course, you could have seen even a very longer distance, right? But because it is a spherical object, you cannot see. That's what we call it horizon, right? So in the same way, in a black hole, there is a horizon beyond which we will not be able to see inside. Only events happening beyond this event horizon, we will be able to see. This side of the event horizon, we will be able to see. That's called as event horizon. So what is this Event Horizon Telescope? This Event Horizon Telescope is a radio telescope in different parts of the world. So basically, the Earth itself, all the radio telescopes put together acted like one single telescope and tried to image a black hole. When I say black hole, of course, you cannot see black hole because the black hole does not radiate light or electromagnetic waves, nor it will reflect back electromagnetic waves. But then you can see the edge, the event horizon of the black hole. So between 2009 and 2017, data from M86, one black hole, was collected. Okay, M86 star, that's a black hole which is in the M87. Okay, so that particular black hole data was collected. Okay, and then finally in 2017, the image was processed and then given. So that's celebrated as the first image of a black hole. So when you look at a black hole, what happens? Okay, so there is the event horizon, which is depicted here as a black ball, which you won't be able to see. But then next to the event horizon, you would have something called as a accretion disk. What is this accretion disk? Because it's a black hole, it has a huge gravitational potential. So it will be pulling material from the nearby places. Okay. So the materials which are falling towards the black hole will be going around the black hole. So it will be looking like a disk around the black hole. And then in the center, you will have relativistic jets where the matter and radiation from this accretion disk will be thrown out. Okay. So this is what would be happening. And when the material is going very near to the black hole, because they are going at a very high velocity, they will start radiating light, electromagnetic waves. Okay, that's what you see in a white color in this image. Okay, it is this white color area that we are actually imagined. I mean, we have photographed in that disk. So when you look at this disk, what you see is this accretion disk. You know, light coming from the surrounding the black hole. So the black hole is the black part inside it, right? So this is what the Event Horizon Telescope is showing. All the light which is going around the black hole. Okay, that's the light that you are able to see in the image, Event Horizon Telescope. That's why it is called Event Horizon Telescope. So it is actually imaging the event horizon. Although popularly we call it as a first image of a black hole, it's the event horizon that we are seeing in this image. Why this image is considered a very important breakthrough in science? Number one, the image exactly match the theoretical prediction that we had. So which means that our theory is substantiated by observation. So relativity and other quantum mechanics and many of the physics that we are talking about is given more evidence by this particular image that we have captured.
My name is Asta Jain. I'm from Uttar Pradesh. I'm pursuing my graduation from Miranda House, University of Delhi. So my question is regarding artificial intelligence. I'm curious to know how will it affect the future of the way we work And also, given its increasing importance, is it time to include it in our school curriculum? Thank you.
It's a very interesting question and a very timely question where all over the world people are talking about the relationship between artificial intelligence, work, and education. Okay, so these three are up for discussion today in the world because fundamentally the way the artificial intelligence has moved in the last few years has changed the terrain substantially. So let's look at, first of all, what is this artificial intelligence? If you look at the artificial intelligence, the name of Alan Turing is key. He was one of the earliest person to talk about artificial intelligence and also gave a working hypothesis of when do you call a machine as artificial intelligence. So his working hypothesis is something like this. Suppose if there are two rooms, A and B, and there are two objects, A and B, inside it, you don't know. Okay, you are C. A might be a computer and B might be a human being. And there is some way of you are able to communicate with these two people without knowing what is inside. Okay, maybe there is a terminal, computer terminal, you type, and then the other person is able to see the computer terminal on the other side. Maybe something like that. Okay, so you ask various questions. Maybe like, what is your name? How do you like my shirt? Whatever. When you ask various kinds of questions, that chit chat that you do with a human being, maybe intelligent question. Okay, prime number theorem, whatever you want to think of, you ask. The person or machine inside the room give you the answer. So now what you have is a question and the response that you got. From examining the question that you asked and the responses that you got, if you are not able to distinguish whether what is inside was a human being or a machine, then Alan Turing said that it's artificial intelligence. Okay. In fact, the reverse of it we use today. In many systems, it will ask you, are you a human being? Okay, right? In many places, when you log in or if you create account, you have this captcha and all this, right? It's a reverse of Alan Turing's uh, system. Okay, so that's what we use. So if you are looking at a Turing test, that is whether the system inside is a human being or not, if you are going to conduct that test, what should the machine have? Machine should be able to interact with you in natural language. Okay, if the machine is going to give you zeros and one, you will know immediately that's machine, not human being, right? So it should be able to talk to you in a natural language. Second, knowledge representation should be there. Like when you show a banana, the system should be able to recognize that this is banana. Okay, this is raw banana, ripe banana. Many of these things the system should be able to. And then there should be some kind of automated reasoning. And the machine should be able to learn. Okay, because you cannot teach everything to the machine. And the machine should be able to have a vision, that is, it should be able to see, or vision sense should be there. Same way, for example, hearing sense, touch sense. Maybe if you want to have a full test that all the five senses of human being, the machine should be have, right? If really, if a machine has to pass the Turing test. So the quest for building such a machine is what is called as artificial intelligence. So the idea of artificial intelligence and people trying to build such a system began in 1950s post Turing. Okay, but the real breakthrough came in 1980s, because without learning, if you build a machine to give you responses, then you don't really see any intelligence over there, right? It may be faster than you, okay, but it doesn't show any intelligence, right? So there is a machine learning idea came in, and then people started working on this goal from 1980s, and by about 2000 there was sufficient success, and from 2010 new thought called as deep learning has emerged, and through this breakthrough, there is a artificial intelligence boom. So what was largely science fiction in 1950s today looks possible, plausible in near future. Okay, so it uses things called as machine learning. That's a classic machine learning. That's how we started. But today we use technologies like neural network, okay, to represent. Let's take a very simple stuff, like say, for example, face recognition. Okay, in a classical machine learning, you program the computer to look at an image, a face, and look at, for example, the distance between its eye, the nose length, so on and so forth. Okay, to classify the faces, so that when you give a test face, the machine would be able to search all its table and then say that, okay, this face looks more closer to this particular photograph that you have already loaded in the computer. The deep learning is even further. You give a set of photographs. The machine itself looks at various aspects, compares contrast, and the neural network is built. So whenever you give a new image, the machine is able to identify whether this image, this face belongs to that person or not. Whenever you are using Facebook today, when the Facebook is trying to tag, whenever you are posting a photograph, the Facebook is suggesting you tag this face to such and such a person. In fact, the deep learning neural network is actually being utilized over there. So it's no longer a future; it's there in our present. The 1980s neural networks has moved into something called as deep learning. Okay, so where not only photograph taken from one angle, but any angle, even if it is a side picture, the deep learning is able to identify that person. Like you do, for example, when you are looking at your friend, even if you are going to look at the friend from back, you know that that is your friend, right? So in the same way, computer systems are becoming more intelligent in identifying, for example, face. I'm just giving you an example of face. Multiple things you can talk about. But still, there are some big challenges in the artificial intelligence system. Like, for example, in this particular case, when the banana was kept alone, most of the artificial intelligence identified it as a banana. Image recognition software identified it as a banana. But when a sticker was placed next to it, the image recognition software identified it as a bread toaster. Bread toaster. There is not even a connection. Okay. So today, what people are pointing out that if artificial intelligence is making mistake, it's making stupid mistake. Of course, artificial intelligence today is very smart, very fast. Okay, but there is still a huge challenge in artificial intelligence to go further. This is what you are saying. Like, for example, today, just go on Google. For example, you put a word like girl and image search. This is the kind of set of images that you will get. If you look at these images, you would find that most of the images, you are using the word girl, but most of the images belongs to European. Okay, very few African, very few Southeast Asian. And then the representation of African, for example, in these images, if you look at, you would not find African with let's say a cheery face. Okay, so the tone, image tone, would be not something positive. Negative images, what is more. So there are also inherent bias today in this artificial intelligence that people are pointing out, and then they are saying that we need to be very careful at this point of time, not believe that artificial intelligence has come to a mature situation. Like, say, for example, Google, which uses huge amount of artificial intelligence to suggest you ads. Okay, when you use Facebook or even ordinary Google, you find ads coming in the side, right? Those ads are personalized. So it is looking at your background profile, the kind of thing that you do in the digital space, and then decides what would suit you, and then it's pushing. So surprisingly, when people started auditing this system, they found that this system are sexist. For example, women are less likely to be shown ads for a high-paid job, even if you are qualified. Okay, so there are problems of this kind in artificial intelligence. Okay, uh, today when we talk about artificial intelligence, as I pointed out, it's come to a stage where it can impact the way, for example, we produce things. Artificial intelligence combined with, for example, 3D printer, nanotechnology can completely change the way, for example, we do production as of now. Today, if you look at, I mean, we are following a production process which was established during the Industrial Revolution. Mass production. There is a machine which produces copies of same thing again and again. Okay, that of course helps you in standardization and so on, but then it's there is no individual difference. Okay, right? With the 3D printer, what you can do is that you can individually produce things for a specific need in an industrial fashion with artificial intelligence enabling it. With artificial intelligence, there is the role of human being can be substantially reduced. Okay, so these are all huge challenges that are before us in terms of what would happen if artificial intelligence is able to take up lots of jobs. Okay, then what would human do? What would be the nature of human work? Okay, that's a challenge. These are all important questions that are being pondered today. This whole phenomena, people are calling it as fourth industrial revolution. Okay, fourth industrial revolution, and then scholars are pointing out that we are in the verge of entering into this fourth industrial revolution. So we need to, as society, imagine how we are going to structure our society, how we are going to take advantage of this new technology to provide for all, okay, and maintain social harmony. Now, coming to the question of introducing artificial intelligence in school curriculum, many people very simplistically think that artificial intelligence is coding, and then they think that teaching coding is enough. It is very similar to the simplistic notion that people had in the 1990s when people started saying in India that we should start introducing computers in school. So what was there? I mean, for example, in a primary school, I remember a primary school textbook, which was called as computer science. So what it had a picture of a computer and said that this is monitor, this is hard drive, this is floppy disk. No, that's not education. That is naming things. Okay. So if you are going to look at artificial intelligence in education, coding is not the way to start with. It is the way we have to start with is that the principles of artificial intelligence. How does the intelligence work? Okay, how do we make intelligent decisions? Those aspects needs to be also find part of curriculum, and that's how we need to build a artificial intelligence curriculum. So questions like, for example, decision making, data analysis, these are all some of the important aspects that we need to look at. And then the difference between correlation and causation. I mean, when you are looking at big data, there is a huge chance that you will mistake correlation as causation, right? So some of these philosophical aspects are also needed in school education.
Recently, Raman Research Institute published in one of their study about positron. So could you please tell me what is this positron and what significance does this hold? Thank you.
Very interesting question. Let's start with the first understanding what is positron. Before that, let's re-look at atom. We would have studied in school that inside atom there is electron, and inside the nucleus there is a proton and neutron. Positron is very similar to electron. Okay, but the mass is same and so on. One important difference between positron and electron is negatively charged, but whereas positron is positively charged. Okay, for electron, you have a complementary particle called positron, right? In the same way, for example, there is for proton, there is something called as antiproton. What is this antiproton? It's same like proton in terms of mass and so on and so forth. Important difference being that proton is positively charged, but whereas antiproton is negatively charged. So in physics, we divide this into two classes. One we call as matter, proton, electron, neutron, matter. Then the other class we call it as antimatter. So anti-proton, anti-neutron, we don't call it as anti-electron, it's called as positron. Okay, so positron as antimatter. In fact, we use positron in our everyday life. Whenever you have taken a PET scan, PET scan, it's a positron emission tomography. Okay, so in fact, we are using positron to scan our body for medical purposes. Okay, so that's a positron. So there is matter and there is antimatter. Now, astronomers do what is called as spectrum study. What is the spectrum study? You look at the sky, that is the universe. You look at, say, let's say, for example, positron. Positrons will come in various energy. Usually, we measure the energy of electron in electron volts, right? So, similarly, you will also measure the energy of positron in electron volts. If you look at the spectrum, what you find is that between 10 giga electron volts and 300 gigavolts, electron gigavolts, the positron seems to be more than what your theory is predicting. So it was a mystery. How extra positrons are created? Where is it created? How is it forming? Because in this universe, the dominant is matter. Very rarely you find antimatter. Okay, so how does this positrons are created was a mystery in astronomy. Some people did studies earlier and then they said that perhaps these are all created in pulsars. Pulsars is a kind of a star which is spinning very fast, close to the speed of light. It is spinning at that rate. Okay, so they said that they are emitting positron. Perhaps that accounts for the extra positron that we are seeing in the sky, in the cosmic radiation. Okay, part of the cosmic radiation. Raman Research Institute people did extensive study, and what they have found is that these positrons are created in hydrogen gas clouds which are there in the universe. Okay, somewhere, for example, some cosmic ray is created. When that cosmic ray comes, in between there is a hydrogen gas cloud, there is an interaction, and in that interaction, the positrons are created. So it's an explanation for a mystery about the universe, that why we see so much of positron in this particular energy spectrum, that is 10 gigavolts, 10 electron gigavolts to 300 giga electron volts. This range, why we see this extra positron. That's what it was solved. What is its significance? Its significance is that one important piece information about our universe we are able to understand. So we are able to understand how good this our understanding of physics and universe is. Of course, this is only a starting point. the research team itself has pointed out that they studied a few clouds. They need to study further clouds to get more evidence to make this as a strong claim.
Hello, my name is Divyank and I am a student. My question is, what is the working of Atman AI developed by DRDO? And what future does it hold? Will it make current CT scan obsolete?
Actually, it won't make the CT scan obsolete. What they have done, let me explain. Okay, we all know face recognition. I mean, this that we have seen in our Facebook. Whenever you post a group photograph, the Facebook is trying to tag, right? So the Facebook is able to identify the face, right? Similarly, for example, some of our mobile phone has that ability that to unlock. You show your face, that mobile phone is able to unlock, right? So again, facial recognition. Similarly, there is something called as object recognition. So you are not recognizing your face, but you are recognizing objects. Okay. Look at this image. I mean, very similar to the Facebook face recognition. Here, Google has developed this image recognition software. What does this image recognition software do? Like Facebook tags different faces. Here, the software is able to recognize objects. For example, in one place, I mean, it is able to recognize TV or monitor. So it is not clear. Till now, it is not clear whether it is a television or a computer monitor. So it is able to recognize the cat. Okay. You can also see that it is able to recognize banana and orange. So it is giving you those labels through artificial intelligence. In the same way, you can also train the artificial intelligence to study X-rays. What do you do when you do a X-ray? You take a X-ray, the radiologist looks at it, and then looks all the black and white and gray area, and then say that maybe you have this disease, right? So this wealth of data is available. Okay, you have X-rays and the disease associated with it. Which part of that X-ray show you that you have that particular disease? Let's say, for example, COVID. Okay, chest X-ray, right? So you present it to artificial intelligence and then make the artificial intelligence recognize. So what the Atman has done is that it has taken the X-ray images of people who are afflicted with COVID. Okay, give it to a artificial intelligence system. So that artificial intelligence system with a radiologist put together, train the artificial intelligence system. So now what will happen is that the moment you show a new X-ray, okay, not historical X-ray, X-ray taken earlier, but X-ray, let's say, of a patient who thinks that perhaps that person is suffering from COVID. If you give it to this artificial intelligence, that is this Atman, it will be able to recognize from your X-ray whether you are infected or not. Okay, and the chest X-rays will show you infection even when, for example, RT-PCR is not able to detect. Okay, so you will have a much more foolproof mechanism for detecting COVID. So this is cutting edge technology that is using deep convolution neural network. The DRDO has built this artificial intelligence system called Atman to detect COVID from X-ray. This does not mean that the CT scan machine is not useful or X-ray machine. That's where you will take the images. A human expert will not sit and look at those images and say that you are affected or not. Okay. Now automatically it can be detected. So it means that large number of people can be X-rayed and then you can find whether they are afflicted with COVID or not. That's the innovation that DRDO has.
Hello sir, I am Ujjwal, a student of class 12. My question is, how does a lithium-ion battery works and what are its limitations? Thank you sir.
Lithium-ion battery has made world very different. In fact, it got a Nobel Award recently. Right from our mobile phone to the future electric mobility, people are banking on lithium-ion battery. Why? Because in small area, you can store huge amount of energy. If you look at the traditional batteries, whether it is the dry one or the liquid one, and look at its volume and the amount of electric energy that you can save there, uh, compared to lithium-ion batteries, they are way behind. Okay. So when you want to use electric mobility or use electric motive power for various places, then you need concentrated energy, and that's what lithium-ion batteries are promising to provide, and it's providing. Without a lithium-ion battery, I don't think so. The current generations of mobiles would have been possible. Okay, otherwise it would be very heavy with huge battery space being occupied, right? Not available for electronics. Okay, let's start looking at how lithium-ion battery is structured and how does it work. Okay, in the positive side, okay, you have cobalt oxide, okay, and in the negative side, you have petroleum coke. That's broadly the kind of material that are being used, okay, and the lithium ion or what is used for storing energy. So when you charge, what happens is that the lithium ions are sitting in the positive side, okay, and I'm sorry, in the petroleum coke. So when you are releasing, when you are using the battery, the positive charge is able to move from here through a barrier, which permits only the lithium ion, not other materials. Okay, so it's a semi-permeable kind of barrier. So through which it moves. So now the electric charge is able to rotate. Okay, the electric charge is able to move. So electric current is produced. So you can light a lamp or use it for any purpose. Okay, so this is the simple structure of how a lithium-ion battery is structured. Okay, one of its major problem is what is called as Whisker form. Okay, so basically the lithium becomes crystallized and it forms dendrites. It's like a small tube-like structure. From the negative to positive it forms, and when it touches, it means it's short circuit. So which means that the battery will die, in worst case burst into flames or explode. This is one of the major challenges. Okay, so some or other you have to stop the development of this. Let's understand how it happens. Okay, suppose when you are charging, okay, so the ions are moving from the positive sides to the negative. Okay, this is at the charging position. Okay, not when you are using the battery, when you are charging the battery. So the ions are moving toward the negative position, and then it's all accumulating in the negative position. So this barrier is able to permit only the lithium ions to move, so the lithium ions are moving. But when it is overcharging, meaning that you have put the battery for charging for beyond, well, we do it often, right? So when you do it, more charges accumulate and it doesn't have space. Okay, so it starts accumulating at the negative end, right? So now they don't have actually a space to sit. So they are gathering around the negative space, right? So because of that, what can happen is that slowly and steadily they can get crystallized, and the crystallized material can extend, form dendrites, create short circuit, and then the battery can burst into flame. So what are people trying to do? They are trying to find a way of putting the barrier very close to the negative terminal, so that the even when overcharging happens, the ions are not able to move there and crystallize. Okay, so people are working on it. So this is one of the major challenge in lithium-ion battery: how to prevent the dendrites from growing. Okay, so people are working on various technologies to find a way out.
Thank you everyone for watching this show. Please like, share and subscribe and keep watching Bharata First. Thank you once again.